Hello friends, today I'll be talking about the problem 36 officers problem. This problem came up in late 1700. The problem is you have 36 officers, each having a rank out of 6 ranks and each having a regiment out of 6 regiments. And each officer has different combination of ranks and regiments. Now one has to place 36 officers in a 6 by 6 grid in such a way that in any row or in any column there is no duplicate in ranks, and in any row and in any column there is no duplicate in regiment. So the problem reached Leonhard Euler, and he framed the problem and named it as Greco-Latin square. This is a problem of constructing order 6 Greco-Latin square. He denoted the ranks by Greek letters and regiments by Latin letters and called them and the one to first to call them Greco-Latin square. So it's a problem of constructing Greco-Latin square. Euler tried a lot and failed, and after 200 years in 1901, mathematician the French mathematician Gaston Terry did an exhaustive enumeration of all the 9,000 cases and proved that it is impossible to construct a order 6 Greco-Latin square. So what I say now is that okay, it is impossible to place 36 numbers 1 1 1 2 1 3 up to 6 6. There are 36 numbers, 2-digit numbers possible with digits 1 to 6. So it is impossible to put 36 numbers in a 6 by 6 array such that in any row or in any column there is no duplicate in first digit, and also in any row and in any column there is no duplicate in second digit. So that construction is impossible, but how far you can go? So let me try it. Let me refresh the screen and start with randomly putting 2-digit numbers with digits 1 to 6, and this is the count of blank cells. I started with 36 and it is 19 now. So let me put some more random numbers. Let me see how many we can put. It's trying randomly, selecting a cell and selecting a number and trying to place the number in that cell. So there are still 11 blank cells, and it is okay, 10 blank cells. Okay, now I shall go manually and try to see. So there is no choice for this 1 5 cell. The row allows these numbers, the column allows these numbers, and there is no number that is allowed by both row and column. Let me see how far we can go. We still have 10 blank cells. So we have 15 and 45 that is allowed in both row and column, but it has a problem that 15 has already appeared, so it cannot come twice. 36 numbers has to come once each. None can come twice. Still now 10 blank cells. So this is the trial and error method. There is no construction available for order 6 Greco-Latin square because it is impossible. So now the number of blank cells is 9. Now it is 8. So one has to go on using trial and error to put the numbers. So here 14 is allowed in both row and column. So let me try it. Okay, the number didn't increase. I still have 8 blank cells. Maybe another easier way of doing will be to use the sequential method. Okay, so let me try the sequential method. No, I'm not being able to go below 8. So let me try the sequential method. So 1 1 1 2 1 3 1 4 1 5 1 6. I'm putting the numbers in sequence: 2 1 2 2 2 3 2 4 2 5 2 6 3 1 3 2 3 3 3 4 3 5 3 6. Then 4 1 4 2 4 3 4 4 4 5 4 6. Then 5 1 5 2. This sequential method places all but last in numbers. So last 6 blank cells are remaining, and this works fine for odd order Greco-Latin squares. Now let me do some trial and error method to see if I can reduce the number further. Still the number of cells, blank cells, is 7. Anyway, one has to try in this way to reduce the number of blank cells and see how far you can go. What is the maximum number of cells you can occupy in a 6 by 6 Greco-Latin square. And today morning I got this arrangement, 22nd March 2024, Friday, 12:15 p.m., where I could place 34 numbers. Only 2 are remaining blanks. So this is quite an achievement. Having one blank cell is impossible. You can prove mathematically that having one blank cell is impossible. So this is the minimum. This is the farthest we can go, which is 34 or 2 blank cells. Thank you. I'll stop here.